Hello, welcome back to the channel. In this video, I am going to discuss Cambridge O-Level Physics, Paper 2 Theory. October-November 2024 paper with code 5054/21. Are you ready? Let us get started. Let us look at the first question first. A trolley of mass 0.2 kilogram is at rest. When I see the word at rest, first thing I do is that I just underline this word and I'll just write initial velocity or initial speed is equal to 0. Easier for me to do my calculation later, to perform my calculation later. So you can use my technique to do it as well. And then when I look at this mass, I just put a symbol there. So I put a symbol. The reason why I put up all these symbols here is to give me some idea on what formula or what kind of equation that I'm supposed to sub in, right? So at rest on a frictionless surface, a block of wood is attached to the trolley. Volume of the block of wood is 0.0012 meter cube. This is volume. I put it as capital V. And the density of the wood is 650 kilogram per meter cube. And I put a symbol of density. This is called rho. RHO rho. A, calculate the combined mass of the trolley and the block. Since I have the mass of the trolley, but the problem is I don't have the mass of the block. How do I find the combined mass of the trolley and the block, right? Aha, look at the density of the wood is being given. The block is made from the wood. So I'm going to use density of the block is equal to, because the block is made of the wood, so it is supposed to be, okay, it is okay, I don't want to confuse you. I just write density of the wood. How about that? Because the block is made from the wood. So this is the density of the wood is equal to the mass of wood over the volume of wood. Now I need to find the mass of wood, so I'm going to write down mass of wood is equal to the density of the wood multiplies by the volume of the wood. Density of the wood is 650 kilogram per meter cube and the volume of the wood is 0.0012. So you have to use your calculator to do the calculation. So I get 0.78 kilogram right here. Now, since I have the mass of the wood or the mass of the block, it is easier for me to find the combined mass. I put it as mass total is equal to the mass of the trolley plus the mass of the block. Please be reminded the mass of the block is the mass of the wood because after all, the block is being made by the wood. So the mass of the trolley is 0.2 kilogram plus the mass of the block 0.78 kilogram. So you should end up getting 0.98 kilogram. So 0.98 kilogram is the answer. B, Fig 1.1 shows that a student attaches a spring constant. I would like to write my spring constant as K to the front of the trolley. The student holds the trolley and block and stretches the spring. He releases the trolley and the block. The trolley and the block accelerate from rest. Start from rest, not moving. As the trolley and the block accelerate, the student keeps the extension of the spring at 0.035 meter. X represents the extension, the symbol of extension. The first one, calculate the force exerted by the spring on the trolley. Whenever you see extension is being given and the spring constant is being given, and you need to find the force on the spring, recall Hooke's law. Hooke's law states that force is directly proportional to extension beneath the limit of proportionality. So if you want the equation of Hooke's law, F equals Kx. Just use this. Now to find the force, spring constant is being given. Let me scroll a little bit, which is 14 Newton per meter. But hey, before you sub in the spring constant, you have to make sure that the unit of spring constant tally with the unit of extension. This is the spring constant, Newton per meter. Okay, per meter. So the extension is also in meters, so I can just sub in 14 times 0.035 and I got 0.49 Newton. So 0.49 Newton is the force exerted by the spring. Second part, the trolley and the block pull a distance. Okay, this is a distance. Be careful, this is not extension. Pull a distance 0.86 meter by the spring. Calculate the work done on the trolley. Now, okay, work done. Do you still remember the definition of work? W is equal to force multiplies by the distance. So work is a scalar quantity, but before you sub in the distance, you have to make sure that force and distance occur in the same direction. Let me give you more example. If you look at the question, trolley and block are being pulled by the spring. So the spring is pulling the trolley and the block, yeah, in one direction. So the trolley and the block must move in that direction of the pulling force. Now, the force by the spring is 0.49. The distance moved is 0.86. So the answer is 0.42 joules. The unit of work is joules, so 0.42. Just sub in two significant figures. That will do. Now, the next question, explain why the power transferred to the trolley and the block increases as the speed increases. Now, when they talk about the power, I would not answer the question just yet. I just put in some equation to make you understand. So the equation that I used was, so you remember the definition of power? Power is defined as the energy per unit time. In this case, because the trolley and the block are moving, so I am putting this energy in terms of kinetic energy, which the equation is half mv squared. Sub into the equation of power, I have power equal to half mv squared over t in this case. And I know that the mass of the trolley and the block is constant and the time taken is also constant. So m and t, I have to make sure are constant first. Then only I can say that half is just a number. Power is directly proportional to speed squared. So whenever, right, the speed increases, the power will also increase. How do I know the speed is increasing? Because look at this part. Look at this part. I'm going to use the highlighter. Trolley and the block accelerate. Accelerate meaning to say that the speed of the trolley and the block is increasing. So that is why I'm using this power, okay, this equation. Power is equal to half mv squared over time, right? Where, since I put in equation, I have to explain every symbols that I use. P equals to power, M equal to the combined mass, V equal to speed, and T is the time taken. So since M, T are constant, I would say that power is, since I have already explained the symbol, so I can just use the symbol to do my explanation later. Power is directly proportional to speed squared. So that is why when speed increases, power increases. That's the answer. Now, let us go to the second question. A student makes a ball from modeling clay. The ball has a mass of 0.2 kilogram. This is a mass. She drops the ball from a height of 40 meters above the ground. Let me draw it. So this is the height. Okay, let's say this girl, oh, I'm sorry, this is a student. Okay, on a tall building. Okay, this is the ball made from the modeling clay. The mass of the ball is 0.2 kilogram. So the distance between the ball and the ground is 40 meter. I'm so sorry. I'm so bad in drawing. I hope that you can accept this drawing. Right. Now the first one. A, part 1. Calculate the initial gravitational potential energy. Now, let me explain. What is gravitational potential energy? Gravitational potential energy is the energy possessed by this ball due to the position of the ball measured from ground. So that also means that if the ball has a height from the ground, the ball has gravitational potential energy. In this case, the ball, which is 40 meters above the ground, has initial gravitational potential energy. And the equation of the gravitational potential energy is, I'll just write down GPE. Stands for gravitational potential energy. It is M times G times H. M represents the mass, G represents the gravitational field strength, which is 9.8, and H is the height measured from the ground. So that is why I use 0.2 times 9.8 times 40 meter, and I got 78.4 joules. I put it in terms of three significant figures. 78.4 joules is the answer. And the second part, calculate the speed of the ball immediately before the ball hits the ground. Ignore the effect of air resistance. Now, this is a super duper good news. When they ask you to ignore the effect of air resistance, our calculation is very, very simple. So we just use the principle of conservation of energy, which states that energy cannot be created nor destroyed, but can change from one shape to the other shape. So you have to identify the initial energy of the ball, which is totally being transformed to the final energy of the ball. Initial energy of the ball is actually gravitational potential energy because the ball is at rest at a certain height, right? So when the ball is released, the ball moves towards the ground. So all the GPE is transferred to kinetic energy of the ball. So GPE is the energy that you have calculated initially, which is 78.4. So I'm just going to sub it in. And KE is the kinetic energy, so which is half mv squared, where m is the mass of the ball, v is the speed of the ball. So I'm going to sub it in. 78.4 is equal to half mass of the ball. Don't you think it's given, which is 0.2 kilogram? So I'm going to put that as 0.2 and speed squared. Now I'm going to make speed as the subject. Speed is equal to 78.4 times 2 divided by 0.2, and you square root the whole thing. You are supposed to get 28 meter per second. So 28 meter per second is the answer. Now B, when the ball hits the ground, it stops moving. Kinetic energy of the ball is transferred to the internal energy, and the temperature of the ball increases. First part, the specific heat capacity of the modeling clay is 1,400 joules per kilogram per degree Celsius. Calculate the maximum possible temperature increase of the ball, and you have to show your working. When the specific heat capacity is being given, equation, the only equation that you're supposed to use is E equal to mc change in temperature, where E represents the thermal energy or the internal energy, M represents the mass of the ball, C represents the specific heat capacity, and delta T represents the change in temperature. Right, E. Okay, I need to find the thermal energy or the internal energy. It seems to be not to be given by the question, but don't worry. Could you read this? Kinetic energy of the ball is being transferred to the internal energy. And the kinetic energy of the ball is equal to the gravitational potential energy, which is 78.4. So you just sub in 78.4 here. Mass of the ball, which is 0.2, specific heat capacity is given 1,400, and you just times the change in temperature. Change in temperature or the increase in the temperature. Now, the increase in the temperature would be equal to 78.4 divided by 0.2 times 1,400. So I got 0.28 degrees Celsius. 0.28 degrees Celsius is the answer. Now, the last question, suggest why. Last part of second question, suggest one reason only, why the actual temperature increase of the ball may be smaller than the value that we have calculated here. You look at the value that we calculated here, this is 0.280 degrees Celsius, but in the real life, the temperature increase is smaller than that. Right. I would say that, okay, whenever a question like this is being asked, all you need to do is just use your very good imagination to imagine, when I drop the ball made of clay to the ground, and then, what could have occurred? Why the temperature of the ball increases? It is made of clay. So when the ball hits the ground, don't you think that some of the initial energy is being transformed to sound energy as well? Apart from the internal energy, apart from the heat given out by the ball, right? Due to the friction between the surface of the ball and the ground. So I would say that some of its initial energy is being converted to sound. So that's the answer. If you have any idea regarding the last part of second question, and you have any suggested reason, please do comment below. Now, question number 3. Fig 3.1 shows the gas at room temperature. The gas is trapped in a metal cylinder by a metal piston fixed in position. The metal cylinder is immersed in boiling water and the temperature of the trapped gas increases. A, explain in terms of electrons. You know that inside the metal there are delocalized electrons and the atoms of the metal, how thermal energy is being transferred through the walls of the metal cylinder. Now, when the metal cylinder is being immersed in the boiling water, since the temperature of the water is higher and the heat from the boiling water would transfer to the metal cylinder. So this metal cylinder will absorb the heat. When the metal cylinder absorbs the heat, the atoms or the particles inside the metal cylinder will vibrate even more, right? And beware, this is about the metal. Metal consists of delocalized or free electrons at the same time. So these free electrons will absorb the thermal energy and they gain more kinetic energy. So when they gain more kinetic energy, they can move faster, drift throughout the whole metal cylinder. And whereas the atoms, since they vibrate at higher displacement, so the chances of them colliding with themselves and the free electrons will increase, right? So that is what happening inside the metal. So I'm going to write that down. So I'm going to say that heat from boiling or heat is being absorbed. Okay, easier. Save the word. Okay, heat is absorbed by metal cylinder through, I give you more information, conduction, because there is a physical contact between the metal as well as the water. And then I would say that heat absorb, okay, atoms. So since heat is being absorbed, atoms in the metal gain energy and vibrate at larger amplitudes, I would say. So delocalized electrons, okay, I would say that delocalized electrons in metal are gaining kinetic energy and move with higher or larger speed or move faster. Okay, collision between atoms in metal and delocalized electrons occur more frequent. So that is, okay, those are happening inside the metal cylinder. I hope, okay, you could understand that explanation. If you do not understand, okay, please do comment below. Now the next one, B, the piston is fixed in position so that the pressure of the gas increases as the temperature of the gas increases. First part, state what happens to the motion of the particles of the gas as the temperature increases. So when you see this is about the gas particle or any atoms or any particles or molecules, as long as the temperature increases, the kinetic energy of the particle must increase. So when the kinetic energy increases, so you go back to the definition of kinetic energy or the equation of the kinetic energy, which is half mv squared. Mass of the particles, they are the same amount of gas particles, so the mass would not increase, but the increment in the kinetic energy will also increase the speed of the gas particles. So I would say that when they ask about the motion, so you need to tell us that the particles move with higher speed, or the speed of the particle increases, not a problem, right? Now, the second part, explain in terms of particles of gas why the pressure of the gas exerts on the walls of the metal cylinder increases as the temperature increases. Now, I want you to take special attention to this question. This type of question is super duper popular. Now, why? When the temperature increases, I will explain first before I write down any answers. I would say that when the temperature increases, the particles will move because the kinetic energy of the particles of the gas increases. That is why particles move with larger speed, or the speed of the particle increases. So the gas particles, because they are being trapped inside the metal cylinder, so since they have more kinetic energy, they will move even faster and they will collide with themselves as well as the wall of the metal cylinder more often. Right, so the collision gives rise to a larger change in momentum. Rate of change of momentum gives rise to force. Since the greater change in momentum, force will also increase. Right, so when the force increases, pressure is equal to force over area, pressure will also increase. I am going to write down the answer right now. So I would say that in terms of the particles, why? Okay, when temperature increases, gas particles move more vigorously. Try to use the word like vigorously, more random, right? Gas particles collide with themselves and wall of metal cylinder more often. So greater change in momentum of gas particles rate of change of momentum gives rise to force, and force per area or cross-section area of the metal cylinder is equal to pressure. Okay, since force increases, pressure increases as well. So you must be able to explain this part. It is very, very important. If you face any hesitation, you have any doubt, do not hesitate. Please do comment below. Now see, the gas in the cylinder reaches a temperature of 100 degrees Celsius. The piston is released and moved to the right. Temperature remains at 100 degrees Celsius. The pressure of the gas now decreases. First part, explain in terms of the particles of gas, why the pressure of the gas now decreases. Well, the pressure decreases because the piston is allowed to move to the right. I would say that because the volume increases. What to do with the volume increases? Particles are separated. Separated, I'm so sorry, spelling error here. Separated at larger distances. Hence, less collision between themselves and wall of cylinder. That's the answer. Now, the second part, eventually the piston stops moving. I explain why. Piston will keep on moving to the right, until the resultant force acting on the piston is equal to zero. So you might want to ask, where is this resultant force coming from, right? So you know that when the temperature of the gas particle increases, they will push. Push is a force, right? So they will push the piston move to the right. So the piston will stop moving when the pressure due to the gas inside the metal cylinder is equal to the atmospheric pressure outside the piston. That also means that the resultant force acting on the piston is equal to zero. That is when the piston stops moving. So I would say that, okay, the pressure, yeah, resultant force acting on piston is zero. Why? Let me explain, right? So pressure due to gas particles or the force, right? Or the force due to the gas particles is balanced by pressure due to air particles outside or around the piston, inside piston. So you know how to differentiate. You have to differentiate between the gas particles inside and the gas particles outside. That's it. Now, question number 4. A student directs a beam of white light from a filament lamp towards a glass prism in a dark room. Fig 4.1 shows the beam of white light incident on the left-hand side of the glass prism. A screen is placed to the right of the glass prism. Red light is observed at point R on the screen and violet light is observed at point V. A. Draw on Fig 4.1 to show the path of the red light and the violet light between the left-hand side of the prism and the screen at point R and point V. Now, before you draw, this is a glass prism and the light travel from air to prism. That means from less dense medium to denser medium. So you need to, first step, before you draw, make sure that you draw a normal. Okay, a normal line right here. A normal is an imaginary line which is perpendicular to the surface of the prism. Now, what happened? Red light would be refracted more as compared to the violet light. So red light refracted because this is less than to denser. So the light ray will be refracted towards normal. But red light will be further from the normal because it will be refracted even more. I would redraw it. Okay, let me erase this one. I use my ruler so that I can draw better diagram for you. Okay, here, make sure that you draw normal. Okay, this is about normal. 90 degrees. Normal means 90 degrees to the surface. So this is just imaginary line. That is why you need to draw dotted line. So I'm going to use red color represents red light and I'm going to use violet represents violet light. How about that? So this is red color. So red color, let me shift my ruler a little bit. So it will be refracted a bit more as compared to the violet. Is it okay? Better? Okay, a bit more. Okay, but still, okay, angle of incident must be larger than the refracted angle. This is red light. And then violet. Okay, this is a violet light. Refracted lesser. Okay, this is how you're supposed to draw it. Just gonna draw it. Oh. So drawing digitally is definitely is a challenge to me. Okay, done. And after that, okay, just draw arrow to show that light passes through glass prism. And then after that, you still have to draw your normal. I'm going to use the blue color ink pen to draw my normal. Normal, 90 degrees here. Make sure that it is almost 90 degrees. I am just, okay, drawing almost 90 degrees here for violet and for red. Okay, so the violet, okay, since the ray travel from less dense to denser, so the ray will be refracted away from normal. Remember that. So you just draw a line joining this violet ray to where V is. Easier. Okay, where is it? Okay, it is here. So I'm going to draw it. Yep. And then the red light, so before I choose the color, I draw it first. Okay. Okay. A bit more. Okay. So I'm going to draw it. This is red light. Okay, let me draw it. Let me draw it, please. Okay, give me a while. Okay. And then I'm going to keep my ruler and then just draw arrows, right? So, of course, you have to draw more logical ray because I draw it using digital. So it's a bit hard. So it will be a bit bent. Lower a bit, right? So angle of, this is what we call angle of incident. This is what we call angle of refraction. So yes, those are the two rays that you have to draw. Now B, state what these observations show about the change in speed of red light and change in speed of violet light as each enters the glass from the air. So this is 2 marks, so you have to discuss 2 points here. I would say that, okay, speed of both lights um, decreases, which is also true, okay, when both lights travel from air to prism. Speed of light in air is the speed of 3 times 10 to the power 8. Speed of light in glass prism is always lesser. Okay, now that's my first point. And the second point, I would say that um, speed of light decreases. I would say that, but if you want me to compare between red light and the violet light, I would say that red light travels faster. In glass as compared to violet light. That's it. Now see, 5 other colors of light appear on the screen between the red light at point R and the violet light at point V. First part, state the names of the 5 colors and list them in the correct order from red to violet. So I will say after red, this is orange. After orange, that's yellow. After yellow, that's green. After green, that's blue. After blue, this is called indigo. And after indigo, it is called violet, right? Now, state how the frequency and the wavelength of the colored light change going from red light to violet. Now, you have to compare between red to violet in air. Bear in mind, we are still using the equation of wave. Wave speed is equal to the frequency of the wave times the wavelength of the wave. Since all the light, right, with different colors, they travel with the speed of light, which is 3 times 10 to the power of 8 meter per second in air. So the speed here is constant. Speed of all the color will be constant. Frequency is inversely proportional to wavelength. Now I gotta let you know that why wavelength, why red light is diffracted, refracted, right? A bit higher as compared to the violet because the red light has the longest wavelength. The wavelength of the red light is between 600 nanometer to 800 nanometers. So that is why from red light to violet light, the wavelength decreases. I memorized the wavelength, so I have to fill in for the wavelength first. So when the wavelength decreases, what happened to the frequency? Frequency increases. Remember that. F is inversely proportional to wavelength. Now D, on Fig 4.1, point P is shown immediately next to point R. No light is observed at point P, but a detector at point P registers radiation reaching the detector. So state which region of the electromagnetic spectrum is detected at point P. If you memorize, right, the range or the sequence of the electromagnetic spectrum, whether you memorize it in terms of increasing frequency or increasing wavelength, it doesn't matter. This one, I memorized it in terms of increasing frequency. So I start with radio wave, microwave, infrared, infrared, visible light. Okay, I'll stop just here. Okay, this is increasing frequency. Okay, never mind. I'll just write it up for you. Ultraviolet, X-rays, as well as gamma ray, right? So state which region of the electromagnetic wave that is being detected since the frequency is increasing, right? So that is why infrared is detected at P. So I would say infrared is detected at P. Now, number 5. Ultraviolet is a longitudinal wave which cannot be heard by humans as the frequency of ultrasound. Oh, not ultraviolet, I'm so sorry. Ultrasound is a longitudinal wave, which is true, which cannot be heard by humans as the frequency of ultrasound is too high above our humans' audible range. Ultrasound waves cannot travel in vacuum. Why? Right? It is valid to all the sound waves. Why? Because in vacuum, right? There's no air particles. There's no medium to transfer the ultrasound. That is why ultrasound wave cannot travel in vacuum. The energy of the ultrasound cannot be transferred. Right? I said that ultrasound needs medium to transfer energy, and there are no medium or okay, no particles in vacuum to transfer the energy of my ultrasound. That is why. B, describe how a longitudinal wave differs from a transverse wave. So this is a distinction between longitudinal wave and transverse wave. You must have a way to actually this is about memorization, but of course I have a way to memorize this thing better. How are you going to differentiate between longitudinal wave and a transverse wave? But I'm going to write down the answer first before I give you the tip, right? So I would say that for longitudinal wave, vibration of particles, right, are parallel to the direction of propagation of wave. That's it. And then for transverse wave, vibrations of particles are perpendicular to the direction of propagation of wave. This is how I memorize, right? I give you a little bit of tips here. Longitudinal transverse wave. Transverse. This is how I write my answer, 90 degrees. You don't like to use the word perpendicular, you can put 90 degrees, you can put right angles, not a problem, right? For longitudinal, I put along. If you don't like to put parallel, you can also replace it with along the direction of propagation of the wave. Not a problem. That is how I memorize. And I hope it will help you a little bit, right? So now, see, an ultrasound transmitter used for a medical scan produces an ultrasound wave of frequency 8.4 megahertz. In soft human tissue, ultrasound travels at 1,500 meters per second. Calculate the wavelength of this ultrasound wave in soft human tissue. When the frequency is being given, when the speed is being given, just put V equals to F lambda. This is an equation of the wave speed. So I put 1500 is equal to 8.4 mega is 10 to the power 6 and find your wavelength in meter. So wavelength is equal to 1500 divided by 8.4. Remember to put a bracket when you key into your calculator to avoid careless mistake. So I got 1.79 times 10 to the power negative 4 meter. So 1.79 times 10 to the power of negative 4 meter. That's the answer. Now, the next one. The ultrasound wave passes from the soft tissue into bone where the speed of the ultrasound wave is greater than 1500 meters per second. State what happens to the frequency and to the wavelength of the ultrasound as it passes into the bone. Can you see? Passes the same ultrasound, passes into the bone. So you got to remember that frequency must be constant. Unless this ultrasound is being changed to another ultrasound, then only the frequency will change. And using the same equation, V equal to F lambda, F is constant, V is directly proportional to the wavelength. Since the speed is greater, wavelength would have to increase. That's it. Question number 6. A bar magnet can rotate freely around a thin rod through its center. The bar magnet is at rest on a frictionless horizontal surface in a laboratory which is shielded from the Earth's magnetic field. A. State the substance from which the bar magnet could be made. Bear this in mind. Bar magnet must be made from hard magnetic material. Why hard magnetic material? Because hard magnetic material, once it is magnetized, it is very hard to lose its magnetism. One of the examples of the hard magnetic material is definitely steel. That's the substance. B. A thin rod. The thin rod is perpendicular to the top and bottom surfaces of the bar magnet. Fig 6.1 shows a view from above the bar magnet with a north pole and the south pole and the thin rod labeled. Okay, so the question draw on 6.1, fix 6.1 to show the pattern and the direction of the magnetic field around the bar magnet. Okay, bar magnet, whenever you draw, it has to form a closed loop. Closed loop meaning to say that for every magnetic field that flow out from the North Pole must go to South Pole. So magnetic field will flow into South Pole, out from North. So I'm going to draw this. Oh, this is what we call closed loop. And then going up again. Okay. And then here close to the pole, you draw closer, right? Why? Because magnetic field is the strongest close to the pole, right? Into south. And then here, draw further and then closer. So towards south, out from north, towards south. This is called magnetic field. Right? Okay, so if you face problem with the magnetic field, just let me know. Now see, an electromagnet is switched on and a strong magnetic field is created around the bar magnet. Fig 6.2 shows that the direction of the strong magnetic field due to the electromagnet is from left to right across the page. Right, first part, draw arrows on Fig 6.2 to show the direction of the horizontal forces that act on the poles of the bar magnet. Identify which is the bar magnet, the north-south pole given. Now, since they have already explained magnetic field lines due to the electromagnet, and first thing that you have to do, label, which is the north, which is the south. Magnetic field always flow out from north into south, north to south. If you are asked to draw horizontal arrow, remember, south will be attracted to north. So horizontal here. North will be attracted to south. These are the two horizontal forces that you have to draw. So I'm going to highlight that so that you can see it better. This is it. And the second part, describe and explain what happens to the bar magnet when the electromagnet is switched on. Could you see that magnetic field, right, of the when the electromagnet is being switched on, electromagnet has its own magnetic field, and the magnetic field of the electromagnet would interact with the magnetic field of your bar magnet. So due to the interaction between the two magnetic fields, it gives rise to a magnetic force. Right. So magnetic force will cause the bar magnet to turn in anti-clockwise direction. That is what I'm going to explain here. So I would say that what happened to the bar magnet. So I'll say bar magnet turns in anti-clockwise direction. Now, I will explain why is this happening. Interaction between magnetic field of bar magnet and magnetic field of electromagnet gives rise to magnetic force. Right? Since there are two magnetic forces acting in opposite direction as shown. Okay, I want to direct the examiner to see my diagram. Fig 6.2, right? Which gives rise to moment. Right? Moment causes turning effect. Right? Which give rise to the to couple. Or you can say couple. What is couple? Couple give rise to the, okay, I'll write this down. Let me explain a little bit to you. Couple. Couples. Okay, I'm so sorry. Spelling error again. Couple. Couple is actually C-O-U-P-L-E. Right? Couple to couple that causes bar magnet to turn. Couple is actually two forces of equal magnitudes that act in the opposite direction. And these two forces are not joined at one point. This is couple. Couple will always cause turning effect. Right. Now, Question number 7. A filament lamp connected to a 12-volt power supply transfer 24 watt of power. Calculate the current in the lamp. So power is equal to IV. 24 is the power. I don't know. And the V, voltage, is 12. Therefore, I is equal to 24 divided by 12, which is 2 ampere. Make sure that you put your final answer in terms of two significant figures to three significant figures, right? Now, the second part, the resistance of the lamp in this circuit, you can use V equals to IR if you want. V is 12, I is 2 times R is equal to 6 ohm. So 6.0 ohm, two significant figures. Now B, a student has a battery of electromotive force, EMF, 12 volt. The student uses a battery in a circuit with a 12 volt filament lamp to obtain a range of suitable readings and plots the current voltage graph for the lamp. First part, figure 7.1 shows the battery and the filament lamp. Now on fig 7.1, complete the circuit diagram of a suitable circuit. You need to add additional component. But before we draw a circuit diagram, so this is a student needs to plot a current voltage graph for the lamp. So if you want a current, you have to measure the current using ammeter. An ammeter must be connected in series with the main circuit. So series meaning to say that if you want to think it simple, you just connect the ammeter to beside the positive terminal or beside the negative terminal of the battery. That will save you a lot of work. And then since I need to plot the graph, so I have to vary the value of the current. So that is why I use variable resistor. So this is the additional apparatus that I need. And of course, I want to measure the potential difference across the lamp. So I connect voltmeter in parallel. Don't just stop there because I need to label. This is called variable resistor. And this is called connecting wires or connecting LED. This is a lamp. This is the voltmeter. This is definitely ammeter, and I am done with my circuit diagram. The next one. On fig 7.2, draw the shape of the current voltage graph for the filament lamp. You bear in mind, filament lamp is not obeying Ohm's law. Ohm's law, current Vs, voltage graph, it has to be a straight line graph starting from origin. But filament lamp, due to the temperature that is increasing, that is why the resistance of the filament lamp is also increases. That is why Ohm's law is not being obeyed by the filament lamp. Since this is a current voltage, right, graph, so you draw the graph like this. It means that, okay, the resistance is increasing. The ratio of resistance is defined as the ratio of voltage to current. Now, state what happens to the resistance of a filament lamp as the applied voltage increases and explain one reason for this happening. I would say that the resistance increases. Why? Due to the temperature of filament lamp increases. That's the reason. Now, the next question, question number 8. The nuclide notation for the radioactive isotope hydrogen-3 is 31H. A, explain why hydrogen-3 cannot decay by the emission of alpha particle. Now, you have to understand that alpha particle is 42He, helium. How can hydrogen-3, which has a smaller nuclear number, decay to form a larger nuclear number? Not possible, right? So that's the reason. I would say that nucleon number of hydrogen-3 is lesser, or the charge is lesser, right, than alpha particle. So that's the reason. B. Hydrogen-3 decays by the emission of the beta particles to an isotope of a different element. This element is represented in the equation by Q. Complete the nuclide equation for the decay of hydrogen-3. So you have to know that beta particle represents fast-moving electron. Fast-moving electron, the mass is 0, nuclear number is 0, and the charge is -1. So you just balance the nuclear number 3. This is 3 on the right hand side. 1 on the left hand side must be balanced by 1, right? -1 plus 2 is equal to 1. And state the name of the element represented by Q that is an isotope of the helium. Helium nucleus. C. The half-life of the hydrogen-3 is 12 years. Define half-life. You see 2 marks given. Half-life is actually the time. You write down the time, I'll give you 1 mark. Time taken for a radioactive nuclide to decay to half. I want to see half of its original value or original number or original count rate, original activity is up to you, right? So the keywords are here: time, decay, half of original value. Now, the next one, a sample of hydrogen-3 is placed on a laboratory bench next to a Geiger-Müller tube and a counter. The count rate is recorded at the same time on 4 successive days. Table 8.1 shows the count rates obtained. 98, day 1, 89, day 2 drop, and day 3 increases, and day 4 drops again. State why the count rates decreases and increases. Actual reason, we don't know. Sometimes increases, sometimes decreases, and increases again. So I would say that due to random decay. That is why. You cannot predict which radioactive nuclide will decay first. And the last question. Number 9, a stable star in a distant galaxy has a mass that is more than 15 times the mass of the Sun. A. Part 1. State the name of the nuclear reaction that occurs at the center of the star and describe this nuclear reaction. Nuclear reaction that occurs in the star is called nuclear fusion. Fusion. So, describe this reaction. This reaction is actually from the hydrogen nuclei, because hydrogen nuclei wanted to be more stable, so they will undergo fusion. Fusion means they combine, right, to form helium nuclei and, okay, releasing a large amount of energy outwards. Give out a large amount of energy, right? And then nuclear fusion can only occur when temperature and pressure of the core or of star is high enough. That's it. And the second part, explain how this nuclear reaction helps to keep the star stable. Right? So you see, right? Due to the nuclear fusion fused together, right? Sir Isaac Newton once states that when the two masses are coming close to each other, there will be a force between them. The force is called the force of gravity. The force of gravity is trying to pull all these nuclei together, whereas nuclear fusion give out a large amount of energy that wanted to push all these nuclei outwards, right? So this reaction, how to keep the star stable is that when these two forces are being stable, the pressure, the outward pressure is balanced by the inward pressure due to the gravitational force. So I would say that um, nuclear fusion transfer thermal or heat energy outward, right? And um, produces I'm so sorry, produces high pressure, high outward pressure, and produces outward pressure, gravitational force between all these nuclei. As long as all the nuclides have mass, they have gravitational force between them. Gravitational force produces inward pressure. Star is stable when outward pressure is balanced by inward pressure produced by the gravitational force. B, as a massive star approaches the end of its life, going to die soon, it stops being stable and becomes a red supergiant. First part, state why the nuclear reaction can no longer keep the star stable. First of all, it's because the star runs out of hydrogen. When it is approaching the end of its life, there is no more hydrogen to carry out the process of fusion. So that is why the outward pressure cannot balance the inward pressure. So the only pressure that acts on the star is the inward pressure due to the gravitational force, because this is a massive star. So large amount of gravitational force trying to pull the star inwards, right? So I would say that why the star is not stable, it is because star, okay, runs out of hydrogen nuclei to carry out fusion. So fusion cannot carry out. So that is why no outward pressure to balance inward pressure by the gravitational force. So that is why it is no longer stable. So describe what then happens to the red supergiant. There are many possibilities that could happen to this red supergiant, but I'll give you one. So eventually, because due to the force of the gravity that pulling the star, pulling all the particles inwards, right? So a lot of friction occur that gives rise to the heat, right? A large amount of heat is being produced with the right temperature, right pressure, the process of fusion will be carried out again. But this time, because there is no longer hydrogen nuclei, so the process of fusion will be carried out by helium nuclei to produce the product, which is heavier elements, right? And then eventually it gets larger and eventually supernova explosion, a big explosion occur and leave behind maybe a neutron star, right? I'm going to talk about that. Now, I will say that the nuclear fusion, okay, occurs again, but this time helium nuclei undergo fusion uh, and produce elements which are heavier. And lastly, supernova occurs, which is a large explosion occur and leave behind a neutron star. So that red supergiant is now rest in peace, RIP. So that's the end of the discussion for this paper. So if you have any other papers that you want me to discuss, just comment below. And if you need the PDF answer from me, just comment below with your email and I'll send it to your email. Thank you very much for watching and I'll see you in my next video. Bye.